This session will be about getting started on an analytics platform with Power BI. If you guys come across any questions in the middle of the session, you guys can use the chat and drop a message, or after you guys can ask after the session as well. Yeah, highly appreciate that. Let's move further. And for those who guys who don't know me, I'm Thimantha Vidanagamage. I love working with Microsoft data platform technologies such as Power BI, Azure Analysis Services, Azure Data Factory, and so on. The most important thing out of all the details you see in the screen here is my Twitter handle. So please follow me on Twitter at Thimantha. Moving into the agenda for today, firstly, I will take you through some basics of an analytics platform. Later on, we look at the architectural aspect of an analytics platform. And finally, I'll be wrapping up this session by demonstrating how you can get started with an analytics platform in Power BI. Moving further, let's look at the basics of an analytics platform. So, an analytics platform is a platform which is used to store and manage data for analytical tasks. The main purpose of an analytics platform is to improve the data-driven decision making in businesses and other organizations. Uh, Moving into the components in an analytics platform, an analytics platform can have data lake, data warehouse, and semantic model, so and so on. Basically, based on the client requirement, or based on the particular business requirement, such components like data lake, even data warehouse or semantic model, um, it can exist or not exist in a semantic model. So that's entirely dependent on the client requirement or the business requirement. Um, Moving further into the operations in a semantic model, firstly, it's data extraction. This is where data is extracted from various sources into the analytics platform. Data loading is where the extracted data is loaded into a storage component in the analytics platform. And afterwards, you have data transformations where the loaded data is transformed into an optimized way, into an optimized form for analytical purposes. These operations require a data movement tool to be driven. So it could be Azure Data Factory or SSIS, and there are some other tools as well. But mainly it could be Azure Data Factory or SSIS for to drive these operations in an analytics platform. Moving into the semantic model of an analytics platform, a semantic model is a data model that is used for analytical purposes, especially catering the end users. In other words, a semantic model is used by end users to consume data in an analytics platform. So this is the most important aspect of a semantic model of an analytics platform, because this is what is exposed for the end users for their analytical purposes. So this is something that really should be paid attention towards. And also, there are two types of semantic models. Those are tabular semantic models and multidimensional semantic models. Previously, it was just multidimensional semantic models, and later on, tabular semantic models came up. So, and tabular semantic models are a lot more compressed compared to multidimensional semantic models as well from that point of view. Actually, in this session, we'll be using and I'll be demonstrating you a tabular semantic model because Microsoft Power BI only allows you to develop tabular semantic models, and you can only connect to multidimensional semantic models that are created in SQL Server Analysis Services. Uh, so that's something to really keep in mind. And when looking at the concept of a semantic model, it's just a basic concept between facts and dimensions. Uh, a fact is a table with numerical figures, while a dimension is another table that can is which can be used to look at an aspect of a fact. For example, a fact can be sales and a dimension can be region. You can analyze regional sales with the combination of facts and dimensions in a semantic model. So that's just a basic overall view for you on the analytics on the semantic model in an analytics platform. Moving into the analytics platform architecture. So what you see on the screen now is a reference architecture that is recommended by Microsoft for analytical platforms. Ideally, this is called as a modern data warehouse architecture. So the reason for that is the data lake concept uh, that is followed here. So the data lake concept, just to give you a basic overview of that, what happens there is structured, semi-structured, and unstructured data are ingested into a data lake and transformed and cleansed, transformed, and basically prepared for analytical purposes. And you can take business decision with the data that are transformed and cleansed and all that. So that's just a very basic view for you on a data lake concept. So if I explain you this architecture from the beginning, firstly we have different types of data sources, and data is ingested from different types of data sources into a Azure data lake storage, and after that Azure Databricks is used to transform, cleanse, and basically prepare the data, and the basically the transformed data is consumed by the Azure Synapse Analytics, which was previously Azure SQL Data Warehouse. So the transformed data in Azure Synapse Analytics is consumed by the Azure Analysis Services, which is a tabular semantic model in Azure. And afterwards, from the semantic model in Azure Analysis Services, the Power BI reports are consumed, and basically the reports are function with the use of the data in the semantic model. So the analytics platform is everything starting from the data ingestion to Azure Data Factory to the data that is loaded and that is available in Azure Analysis Services. Reports are not part of the analytics platform, so they are separate. They are basically called as BI, business intelligence. So an analytics platform is different from that. Basically BI reporting. That's what they're called. So this is basically an analytics platform. So in here, um, that's the only consideration here is that is the cost incurred and the effort incurred. So in order to implement such a architecture, it can cost you a lot of time and a lot of money as well. So it's quite costly, and if you just simplify what you see, and if you just build even a very small the analytics platform with such tools, you should be able to manage and pay around roughly around 500 USD per month. So that's just a rough estimate from my experience. So it's kind of the and the development effort is high as well. You need to bring in developers, and maybe you need to join in with an external party and do the developments and so on, which can be a lot of effort, and that can be a costly process as well. So just to explain you, if I just take you, if I just explain about this reference architecture a bit more, there is no such thing called that you have to use all these components in an analytics platform. So as per your client requirement, as per your requirement, you can simplify and you can use other alternative resources, and you can build the architecture as per the requirement, as per maybe the cost requirement, as per maybe the workload, as per the data load, and so on. So there are a lot of considerations like that. Based on that, you can simplify and build a model, build a architecture, and from that architecture, analytics, you can simplify and build an analytics platform architecture. So that is it for me to say about this reference architecture, which is called as a modern data warehouse architecture, that is recommended by Microsoft. Moving into the next part, so you can build analytics platforms with Power BI as well. So in Power BI, you use two key components to build an analytics platform. Those are Power BI data flows and the Power BI data sets. So Power BI data flows is a data preparation component. I'll be talking about this further in the next slide. So let's keep that aside for now. And Power BI data set, of course, I think most of you guys who had worked with Power BI know what Power BI data set is. It's basically where you bring in the data, and where you do the data modeling, and where you build the measures for analytical purposes. So even if you don't purposely build a Power BI data set, so even if you just access Power BI desktop, and even if you just import a table from a database and create a simple report and publish that to a relevant workspace, if you go to that workspace and check the datasets, you can see that a dataset is created for that particular report, created in Azure, sorry, in Power BI service for that particular report. So it's like that. It's something really, it's something that's compulsory in any Power BI reports, or basically in any Power BI reports. So that's about it when it comes to the two components. So I would take you through a bit of that, and in terms of the Power BI data flows, since that's something important and something that not everyone is aware of. So the Power BI data flows is a data preparation component that is available in Power BI, where the entire in a Power BI data flow, the entire process is based on Power Query. Power Query is running behind the scenes, and Power Query is used for data cleansing, data transformations, and all that in Power BI data flows. And the key purpose of a Power BI data flow is to consolidate data elements for reuse. So what that means is there are different elements of data, there are different master data, there are different types of data. So what you need to do is maybe what you can do with that is you can basically get the data from the particular source, relevant data from the particular source, add business logics, do cleansing, do preparations, and do the necessary tasks, and keep it ready in the specific data flows, output tables for reuse. For reuse in the sense for reuse by multiple data sets that are in the Power BI model. So that is the actual purpose of Power BI data flows, but we can use it for analytical purposes as well, for to build an analytics platform, to build a data warehouse as well. So there is actually a guide for best practices when it comes to building, and I will be talking about that further. I'll be showing you an architecture and I'll be talking to you about that further. So it's something that's possible as well, but there are certain considerations that you should take into account when doing that. And also with Power BI data flows, uh, it promotes self-service data preparation. So what is this self-service data preparation? Self-service data preparation is where you can do where business users or any users who does not have appropriate enough technical knowledge on data transformations or data cleansing can jump in and do the necessary data cleansing and transformations as per their requirements, and make sure they have output table, make sure they have output tables for their analytical purposes. So that's what a self-service data preparation. That's what self-service data preparation means. That is promoted with the use of Power BI data flows. Moving further on, where this the entities or where the output tables of a Power BI data flow is stored, it's stored in a Azure data lake. Now, most of you guys might think most of you guys who don't have an Azure subscription might think this might not work out because they don't have an Azure subscription and they don't have Azure data lake to store these output tables for their analytical purposes, but that's not how that really works. So you have the output whatever you have in the output tables or the entities in a data flow are stored internally in their own Azure, in a they are dedicated in their own Azure, in Microsoft's own Azure data lake, and that's not really visible uh, for anyone that's done internally itself. But if it is required, I have heard that there are possibilities. If you have an Azure subscription and if you have a dedicated or particular Azure data lake, you can configure the data flows to be stored in the Azure data lake, uh, in your dedicated or in your personal Azure data lake or in your organizational Azure data lake. So that can be possible as well. So this is just an overview for you guys on Power BI data flows, and let's move further into the recommended architecture for analytics platforms with the use of Power BI. So this is the recommended architecture. So if I quickly get you through this, explain the entire process that's here. So we have a data source, and we have a staging data flow, and we have a transformation data flow, and we have a Power BI data set, which is the semantic model at the end. So if I explain to you specifically starting from the staging data flow, what happens there is data is ingested as is, basically data is loaded as is from the data source into the staging data flow, and the tables, output tables, uh, basically data is ingested from the relevant tables in the data source, and those tables are the output tables of the staging data flow. Um, I will show you the entire process. How I would show you, just show you walk around. I would just walk through this in the demo session. So for now, just keep in mind what this is. It just staging data flow ingest the data as is from the data source tables and as output tables. So these output tables from the staging data flow will be used as the input source from the transformation data flow. So what the transformation data flow does is it transforms the data, as I told you previously, for an optimized form uh, to do analytics for analytical purposes. That's what transformational data flows do. And the output of those transformational data flows are basically facts and dimensions, which I mentioned previously. Basically, with this process, you have built a data flow. You have built a data warehouse until the